अस्सलाम वालेकुम। आई होप आप लोग खैरियत से होंगे और एग्ज़ाम्स की तैयारी कर रहे होंगे। अल्लाह ताला आपको कामयाब करे, ना सिर्फ दुनिया के एग्ज़ाम्स में बल्कि हमेशा की लाइफ जो आखिरत है उसके एग्ज़ाम्स में भी कामयाब करे। तो हम लोग बात स्टार्ट कर लेते हैं। आज हम बात करेंगे ब्रेक इवन एनालिसिस के ऊपर। इट इज़ एक्चुअली कॉम्बिनेशन ऑफ डिफरेंट थिंग्स। आप फार्मूला इस्तेमाल कर सकते हैं, यू कैन मेक अ टेबल और यू कैन यूज़ अ ग्राफ in order to find the break-even quantity. Now, what is break-even quantity? A break-even quantity is where total revenues are equal to total costs. At this point, your profit is equal to zero. So firms actually impatiently wait for this day because this is the day when they break even. They have to sell a specific quantity in order to reach this point. If they sell one more unit, they are in the profit regime, and if they sell one unit less, they're in the loss zone. So now the question arises how to compute that. So there are three ways. Normally the data is given as total fixed cost. Please remember, if the fixed cost is given for a month, you have to convert it into yearly data so that you can have a fair comparison. So usually variable costs are given per unit and selling price is also given per unit. If it is not given per unit, you have to first compute 1 unit price and 1 unit's variable cost. So now what are fixed costs? So technically fixed costs are the rent of the space. Imagine you've got a coffee shop and the rent of the building and rent of the shop is known as fixed cost because it does not change with respect to production. Even if you sell or make no coffee, you still have to pay that. The second is insurance. It can be utilities, depreciation of the coffee equipment, any repairs and maintenance of coffee equipment. All of these are known as fixed costs. And usually these are found in total, not in per unit. When it comes to variable cost, the variable cost is the cost of labor and cost of material. For example, coffee beans, any sweeteners, if you are paying the barista who's making the coffee or brewing the coffee per cup sold or per unit, so that is also known as direct labor, which is again a variable cost. Similarly, packaging, you have got cups and lids or any spoons that you have in order to be sold along with each cup. So these are all known as variable costs because they change with respect to production. So now let us compute with given data. You've got total fixed cost of $5,000. Variable cost per coffee cup is $3. Selling price per unit is $8. So the formula goes like this. Total fixed cost divided by contribution. Contribution is selling price per unit minus variable cost per unit. Once again, I'll emphasize the numerator is in total. The denominator are in per units or per coffee cup. So let's plug in the values. Total fixed cost was $5,000. $5,000 divided by selling price is $8 and variable cost is $3. So that is equal to 5,000 divided by 5, which will give you 1,000. Rather, this is units because dollar will cancel with the dollar. So it would be 1,000 units, or in our example, you have to sell how many coffee cups? 1,000 coffee cups. So please remember, you have to give the units. 1,000 alone does not mean anything. So you have to supply the units or the shoes or the machinery or whatever you're making. The unit of that should be mentioned in order to gain full marks. Next, let us attempt to make a table for the graph, which is actually part of the exam as well. So let us make the table. How do we make it? First, let us list some quantities on the y-axis. We have got quantity or number of units sold for coffee, total fixed cost, total variable cost that you can have by multiplying the variable cost per unit times the quantity. And total cost is the sum of total fixed cost and total variable cost. And finally, total revenue is selling price times quantity, selling price per unit times quantity. So this is how you are going to populate this table. So let us do that. So now we know that $1,000 coffee cups are the break-even point. So let us choose 500 below 1000 and 500 above 1000 in order to construct a graph. So that's a very good technique to make that. So quantity 0, so that you know some quantities at origin. And then you have got 500 coffee cups, 1000 and 1500. So please remember, if there is a huge number, let us say in millions, you do not need to carry because a million has 6 zeros. So if you want to show it in this table or in the graph, a very good technique to reduce the number of zeros that you have to make is either take this figure and eliminate this one and just mention at once that all of these figures are in thousands. Or you can even further simplify by only saying that it is 1 million. So then you should write quantity in millions. So this is not now 0 million, 500 million, 1000 million, which is actually 1 billion. So this is how you can reduce the number of zeros, and you can also make a very good graph out of it, because if the quantity is very large and fixed costs, variable costs are very small, the graph would be not up to the scale, and you would have a hard time graphing it unless you go into the log or some other kinds of graph. So let us populate this graph. We know the total fixed cost remains same. It is $5,000. So even if you produce nothing, zero quantity, it is $5,000, and it would not change for any quantity. So that was the easy part. Total fixed cost as it is. For zero quantity, for 500, for 1000, for 1500, it remains the same. Now let us make the total variable cost graph. We know the variable cost per unit was $3. So variable cost per unit was $3 times quantity. So $3 times 0, you'll have to plug it over here. Okay. So $3 times 0, if you are making no coffee cup, obviously you'll have no variable costs. If you are making 500 coffee cups, all you have to do is to multiply 3 with $500 and write it here. So that would be $1,500. And similarly, you can complete the whole graph now. You can pause the video and complete the graph, then you can match your answers. So it would be 3 times 1000 and 3 times 1500. So total cost is just the sum of these two. Just add these two and write it over here. Total cost is $5,000 for 0 units. For 500 units, how much is it? 6,500. And then you have got 8,000. And finally, you have got 9,500. Now selling price per unit was $8. So 8 times quantity, 8 times quantity. So you have to multiply 8 with 0 in order to get 0. 8 times 500 would give you 4,000. And similarly, you can complete the graph. If you carefully observe, which is the quantity, or can you find out the quantity where both total cost and total revenue are equal? So that is actually this quantity. At $1,000, if you carefully observe, both total costs and total costs and total revenues both are equal at this quantity. So this is called the break-even quantity. And if someone asks you what is the break-even selling price, or what is the break-even sales and costs, that is equal 8,000. So now we know that break-even quantity is $1,000. Please remember, if in your exams, for example, if break-even is somewhere around 550 or 600 or 700, obviously that would not be shown by the graph. So that is no criteria that your table must have a break-even quantity. You can just make the table and your quantity can be in between as well. Now let us graph it. The thing about all the graphs is you first have to label the graphs. Since you want to show both costs and revenues over here, so you have to write both of them. And if these are shown in thousands of dollars, you can write thousands and then place a dollar sign on top of it. Or if these are only in dollars, so just mention that this is the currency that we are dealing with. On the other axis, we have got quantity or output. Quantity, some people call it production or output. So in our case, that is the quantity of coffee cups. And with your experience, you can have a very good scale. For example, you know that your quantity is varying between 0 and 1500. So on x-axis, you have to go from 0 to 1500. So mark equal spaces, then plot it as it is. So we have got 0, 500, 1000, 1500, and 2000. Now let us go to the plotting side of it. Rather, we have got the y-axis. So y-axis, you know that it is varying from 0 all the way to 12,000. So you can have a very sensible scale of 5,000. So it would be 10,000, and that would be 15,000, and finally we have got 20,000. So this way you can easily plot it. If you, once again I'll emphasize, if you've got a lot of zeros, you can just write 3 zeros above and then get rid of these 3 zeros. You can just write 15, 20, 10, and 5. You can eliminate these in order to have a good graph. So this is the axis. These are the axes that you had to make. So now we are done with the axis. So we have to go back to the table in order to graph it. It is very easy. This is the x-axis value. First of all, let us graph the total fixed cost. Let me graph this in yellow, these two, or I can graph this in white rather. So this white thing, I'm gonna graph first, a white line. So at 0, the total fixed cost is 5,000. So this is your first point. At 0, your total fixed cost is 5,000. At 500, your total fixed cost is once again 5,000. So at 500, once again it is 5,000. So now you know both points. All you have to do is to make a straight line. Although there are many other lines as well, many other points rather, but you don't need to plot all of the points, because for a straight line, you know that the minimum criteria is having 2 points. You can always draw a straight line by using 2 points. So all you need is a set of 2 points. This is your total fixed cost. It is parallel to x-axis. We know that even if the quantity is 500, 1000, or 1500, or it is 0, you still have to pay the same fixed cost. And the graph is starting from 5,000 because total fixed cost was 5,000. Now let us make the variable cost. You can try it once again by pausing the video so that you can compare the graph later. So this is how we will keep on drawing. So total variable cost, let me draw it in yellow. This is the variable cost. 0, 0, the first point is 0, 0, which is actually the origin. So this graph will start from the origin, because if there is no production going on, there is no variable cost. And then you have to make a better judgment for yourself, because 1500 would not be readily available. So you can choose 1500. For 500 units, your variable cost is 1500. And 1500 might be over there. So this is how you can make a straight line out of it. So that would be known as your total variable cost. So now let us move to the graph further, and let us see where our total cost is. Let me draw that in red, this one. So for 0 it is 5,000, it is starting from 5,000. So for 0 it is 5,000, so it is starting from here. And now for 500 units it is at 6,500. So for 500 it is at 6,500, which is somewhere over here. So now you have to draw once again a straight line, and these two lines must be parallel to each other. Total cost. Now we are only left with total revenue. So we have to now plot total revenue. How to plot it? 0, 0. Once again you are at the origin, and your next point is, let us say at 500 it is 4,000. So it is at 500 it is around over here. It is around this point, and this way you can have this kind of a line, and you can see that total revenue line and total cost line are cutting at some point. This point is known as break even. Let me mark the break even with some other color. This point is called break even point. You have to label all of them. And once you drop it down to the x-axis, this is called the break even quantity. Break even quantity. And if someone asks you what is the break even level of sales, so you have to draw a graph on this side. So as we could have seen from the table as well, that would have been 8,000. So you have to show that as well. That's called break even sales, which is equal to break even costs as well, equal to break even, because at this point both lines are crossing each other. So technically they've got the same coordinate point at this point. So we call it a break even sales as well as break even costs. If you don't know the break even sales or break even costs, a very good technique is just multiply your break even quantity with your selling price. So your selling price was $8, your break even quantity was $1,000. So again you get the same answer. So this is the same point that you can find out. Now you have to show the regions as well. So the region that I'm showing in green is the region of profits. This is called the profit region, because total revenue line in this region is above the total red line. So this is called the region of profits. This is the region of profits. And below or behind this break-even point, towards the left, we have got loss region. So if you are selling less units than 1,000, you are in the loss region. As you can see that if you're selling, for example, you're selling 500 units, so just go up, you see that total revenue line is less than total cost line. If you subtract it, you'll get the amount of loss as well. So at any point, the difference between these two lines will give you the profit or the loss. Another pertinent concept is called margin of safety. If your current production level is, let us say, 1,700, if you're currently producing, let us say, 1,700 units, Let me choose a different color so that you can understand this concept. That is not required for my exam, but that's an important concept called margin of safety. Margin of safety means how far away from break even are you currently at. If your actual production is 1700 units, what can be your margin of safety? So margin of safety is actual production minus break even output or break even production. So how safe are you from the break even or the losses? So 1700 minus 1000, so 700 units would be your margin of safety. It's called margin of safety. So with this we conclude the break-even analysis. How did we do that? Number one, we can use the formula total fixed cost divided by contribution. Contribution is selling price minus variable cost. It is called contribution because it covers the fixed cost and it brings in the profits. So that would tell us how much do we have to sell in order to reach the break-even point. The second is to make a table. So how to make a table? You have some things listed on the y-axis, which is in the first column. You can have quantity, fixed cost, variable, and the total, which is the sum of fixed and variable, and finally the total revenue. You have to choose the quantity on your own according to your own question, according to the data set that is given to you. So it is not always 0, 500,000 or 1500. It depends on the data that is given to you. So you have to make a judgment that, okay, if I've got 1 million, so 500,000 and 1.5 million would be a suitable way to do the quantity. So it's up to you. So it's not necessarily that you work according to the break-even quantity. You can choose your own quantities. For example, if the break-even was 375 units, so you can still safely choose this graph. Let us say 0, 250, 500. So 375 would somehow come in the middle. So once again, the choice is arbitrary. It is a random choice. So two students can have a different choices, but they can still reach the same results. And finally, we make the graph. First of all, label the graph, then show all of the pertinent things, draw the cost curves first, and then you have to draw the revenue line, where the revenue line is cutting the cost line. That is the break-even point. Then you have to drop it down to the x-axis in order to get the break-even quantity. This is called the break-even quantity. And finally, you can have the regions of profit, which are above the break-even or towards the right, and towards the left we have got the loss region. Good luck with the exams. I hope you got it. Any questions you can leave in the comments. Take care, and once again, best of luck for the exams. Allah Hafiz.